Saya buta IT sikit ya. Saya tak pandai sangat IT ni, sebab itu saya pun tak dapat tahu lah. Nantilah saya pergi training balik. Tak apalah, you all, dia yang penting you all study tutorial saya. Kalau boleh faham tutorial, basic apa ni, yang lecture note ni you all faham. Kalau tak faham dia tanya, then saya rasa okey kot. You all bukannya apa ni deep sangat macam mechanical lah, so tak ada masalah. Even budak mechanical pun tahu dah saya punya perangai. Perangai saya senang soalan saya. Apa saya tanya dekat tutorial, itulah soalan dia. Itulah soalan final, itulah soalan kita. Itu pun tak dapat A. Mana budak exam ni, aku tak tahulah apa masalah. Agak-agak dia, sebab tu kita temu ni susah kot. So that's why saya suruh you all print thermodynamics table tu kan. Yang tu yang menyebabkan you all tak boleh jawab. Right? So let's start our lecture today. So we look into so now we look into this thermodynamic system. So we continue at this property of the system. Okay. So there are two types of properties for the system. One is known as the extensive property. Another one is known as the intensive property. So to differentiate between these two is very simple. Extensive properties depend on mass, such as volume. Okay. While the intensive properties is independent of mass of a system. For example, temperature. So in case you got fever, whether you are thin or whether you are thick, whether you are huge, and although you are slim like Rina Harun, still you're going to get cold or fever because the temperature is intensive. It does not depend on mass. So whether you are fat or you are thin, you still got fever. So temperature is also depend on mass. Same as the pressure. So whether you are thin or you are big, you are smart, you are not handsome, you are ugly, but still you got stress. So when you got stress, that means the pressure inside your head or your blood pressure is getting increased. Then you still have your pressure can either increase or decrease without the effect of mass. So that is the difference between intensive and extensive properties. Because in thermodynamics we call it extensive properties. Normally we use the word specific. So if a small v, we call it specific weight. Okay, so that is depend on the mass effect. Okay, so specific volume, for example, so V equals to V over M. So volume is kilogram, volume is meter cube, M is kilogram. So kilogram per meter cube, that is specific volume. Okay, so that show that the amount of items that we consider in a thermodynamics problem is either based on mass or not. Okay, so the temperature normally they don't have the effect of mass. Okay, even the density, although the density is rho m over v. Okay, and then now, so these are the piston cylinder device. Okay, so the state, what we call a state. Okay, the state of a system is a condition as described by giving value to its property at particular instant. Okay, so I have a coffee here, I have a water, the green tea here. This one is with milk, with hot, and this one is just a water. Boleh minum gitu. Green tea from last night. Kira lewat semalam, right? So this at state 1. Okay, let's say this is hot. So let's say now it's about 2 kilograms. The temperature is 20 degrees Celsius. The volume is 1.5 meter cube. So this is state 1. Assume that I try to put inside the microwave. So I put about 30 seconds at 800 megawatts. So the temperature is increased. So from 20 degrees Celsius is go into 25 degrees Celsius. And the volume changed to 2.5 meter cube. Change in volume means that the initial volume are the same, but the volume, let's say from water, when you steam the water change into water and steam. Okay, so in Malay we call it from the solid water, so daripada air yang keras. So when you steam the water change into two phase. One is a vapor, one is a solid state. Okay, satu bentuk cecair, satu bentuk uap. So but still, so what become, let's say 1.5, this one become 2.0, 1.0, this is 1.5. So the volume is still 2.5. Okay, it's still 2.5, but the change of volume, the change of the state to dia punya properties tu different. Okay, so macam ni lah, dia ada uap kat atas, dia ada ni dekat bawah, ada normal water. So kalau dipanaskan, there will be more uap. Okay, more vapor. Okay, so that's mean the volume are still the same because it's a closed system. So closed system. Okay, if you look into the left side, it's a closed system, right? Okay, so this is a piston here. Alamak, change color. Apa tu color ni tak cantik, so merah. So this one is a piston. So if you hit the system, so the piston will raise. Okay, so when it raise, so now the mass is same, but the volume change. So the mass cannot differentiate. Okay, the mass will always remain the same. The volume change. The volume change means they will become two state. From just a liquid, it become liquid and vapor. So liquid dengan uap. Okay, so this one is known as steady state. Steady state is what? When the property change, none of it change with time. It's just change the phase. Okay, so that is a steady state. So state 1 to state 2. Okay, so from Melaka to Penang. So state 1 Melaka to state 1 in Penang. Okay, so sama juga. So now we look into a detail. So instead of just a state. Okay, now when we use a word equilibrium, so lepas ni if you hear from TV news or whatever, when you read a newspaper, they say that because of the effect of the thermal equilibrium, there is no problem with the system of the katalah Kowe system. So that means what? There is no temperature differential. Okay, so when the temperature are the same, so it's called as a thermal equilibrium process. And then also we have the chemical reaction. So if there is no chemical reaction, so it's a chemical equilibrium. Okay, so sama juga macam phase is fasa lah. Fasa equilibrium atau phase equilibrium, mass of each phase. So from phase 1 to phase 2. Okay, so bila kita sebut phase later on, phase can be from phase 1 to phase 2. Dekat if phase 1 tu, we call it state 1. Phase 2, we call it state 2. So from state 1 to state 2, we call it a process. The process, from here to here, the line that they flow the process is known as the path. So if the path is can return back from the state 2 to state 1, so it's known as reversible process. If the process cannot reverse from 2 to 1, then it's become irreversible process. So that is related to phase equilibrium. Okay, so if the phase mass of each phase are equal, no change, then it's called phase equilibrium. Yang saya cakap tadi tu phase 1 to phase 2, nanti kita akan tengok aja. Okay, and then mechanical equilibrium is what? There is no change in pressure. Contoh macam bekas air ni, it's known as mechanical equilibrium because there is no pressure change. Okay, so before and after, let's say the temperature, let's say you have 20, 23, 30 degrees Celsius, 35, 40, 42. So after you heat, then it's equilibrium. So, okay, so that is also called as equilibrium. This one is a phase equilibrium. Okay, yang saya cerita tadi tu. So process. So process is what? Any change that a system can undergoes from one equilibrium state to another. Contoh saya jalan daripada pintu situ, daripada bilik saya ke bilik study saya. So from my bedroom to my study room, So from a bedroom is what state 1. So different air conditioner, different temperature room. Okay. Then from state 1 in my bedroom, come into my study room. So it's a process of walking. So we call it a process. So in thermodynamics, a process is known as the change from a state undergo from one equilibrium to the second equilibrium. So from room temperature of 22, now it's about 24 because I didn't switch on the air conditioner at my study room. So it is a state 2 now. So the process of walking is known as path. Or in other words, we call what does it mean by path in thermodynamics? Path means that the series of states through which a system passes during a process. Okay, because throughout the process, apart from my room to my study room, so probably I feel some of feelings because the lighting is coming in, there is no cahaya silence. Process is the process of swing, but when it comes to state 2, that is the end of the process, then is become this what we so called as state 2. Okay, so there is also a process that is a very, 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 very sufficiently slow process. So if you're a slow learner, then you can call yourself as a quasi-static learner. So in the process, we call it quasi-static equilibrium. Okay, so quasi-static equilibrium is what? Sufficiently slow process that allows system to adjust to itself internally. So it's a very slow process. If you look into on the right figure, so you can see that although you give it a fast, so the change or slow, the change in the molecule inside the system is very, very slow. So almost it doesn't change at all. Okay, but it's changed. Okay. All right. So it's not a quantitative. So if you are late, if you learn very slowly, you wake up very late from your bed to the time that you were your attire. So it takes about 30 to 40 minutes, especially the girls. So that's me, you are quasi-static in your process. So try to avoid it. Right. So now a cycle. Okay, from state 1. If the cycle can return back, it's known as reversible cycle. Okay. Okay, and normally the state of the initial and the final are identical. If the state of the initial and the final are identical, as a cycle. So cycle. So like that. Why do they call a bicycle? And bi means 2 tire. Cycle means what? You cycle the pedal. So when you cycle the pedal, so you made the at the end of the process. So that's why we call it bicycle. Tapi orang Kedah panggil beskar. Orang Kedah tak ceria sikit. Right. So if there are isothermal process, okay, so when it's called isothermal process means what? There is no change of temperature. Okay, so if you look into this figure, so from state 1, you give force ataupun hit the system, so the piston move into this one to the state 2. So now if you look into this one from state 1 to state 2, you see the decrease in volume, okay, but increase in pressure. But when you return back, or let's say you remove this heat, and the piston will return back to the initial position, so the volume will decrease back to and also the volume will also increase back to the initial volume. That is known as a cycle. Now you know why they call it bicycle, they call it cycle. And then we look into the isobaric process. Okay, if you say, macam mana nak hafal isothermal process ni, how to memorize this thing? So thermal is what? Thermal is related to the temperature. So if iso is what? Iso ni constant. So isothermal process mean constant temperature. So iso, this one is what? Pressure, the unit is what? Bar. So process is a process lah. Iso is what? Constant. So pressure constant is what? Isobaric process. So the English they use IC here. It's the particles that they use here. And then isochloric and Clorox. You remember Clorox that your mom used to clean to wash clothes, and so it's a Clorox. It's a chloric. Okay. So and then iso is what? Constant. So it's known as the specific volume constant ataupun just a volume constant. Okay. So that's are the things that's known as terminology for cycle. Kenapa saya ajar this kind of words, meaning and definition? Why? Because when you read later, the question in the exam ataupun the problem that state in the assignment is that if you don't understand the word cycle, the word isothermal, how can you interpret that state punya particular properties? So that's why these words means a lot. Okay, in other words, it allow you to interpret the state one. So this, let's say in the question say the process of the temperature for the process is isothermal process. So that means there is no change of temperature. Right. So itu yang interpretation. Okay. So these are the words that you have to use to understand. Okay. Lepas tu kita ada perkataan steady, unsteady, and uniform. So if the mass go in and mass can go out at no change of time, so that is called a steady. Sebab tu ada lagu apa? Tu lagu relax brother, relax kan. So ni lagu steady brother, steady relax. So it's no change of with time. So what about the unsteady? Unsteady is change with time. So if there is change with time, then it's called unsteady. So you pun sama juga lah. Kalau you moody selalu, so you are unsteady punya person lah. So if you are uniform, so that's why uniform, that means no change with location. And so macam budak sekolah, so the school girl and school boy wear a uniform. So there is no change of location. As long as they wear this kind of uniform, they are in school. So as long as the police wear the uniform, then they are policemen. And if they wear the uniform of the fire brigade, then it's called a fireman. And dia macam bomba lah. Why they call it bomba? Bomba is what? Badan Operasi Mencegah Bencana Api. That is the short form of bomba. Lepas tu dia panggil Jabatan Bomba dan Penyelamat. Kalau dia sebut Jabatan Bomba saja, so kalau kereta api kereta berlanggar terbalik, dia tak boleh pergi selamat lah. Sebab dia bukan, dia kata kami padam api kan. Baik. Pandai kan dia bagi nama bomba. Nama pun sedap je. The best tea is what? The tea made by me. So it's a natural milk. So the natural milk, so milk have two types of milk. Ni cerita-cerita je lah. So one is known as normal milk ataupun the whole milk. Another one is skim milk or semi-skim milk. So skim is what? They take out all the fat. And they take out all the fat. So it's become skim milk. Okay. So another one is milk. So the process is known as pasteurizing. Okay. Ataupun apa? Kita ingat lah dia punya apa. Right. So itu iklan sekejap lah. Sebab tengah minum air kan. Okay. Now we look into the pressure and temperature. Ni budak dia tengah kena COVID lah. So the type of the pressure. So the absolute pressure is actual pressure at given point. So pressure is what? Force divided by area. So saya pun tak ada penutup. So if you listen to this one, let's say I put my phone on the top of this phone, top of this plastic container. So automatically I will feel that there is a heavy. Something has become very heavy. Why? Because there is a force here. So the amount of force here over the area of this plastic container, okay, F divided by A, that is the pressure that the one that I hold this bottle or this plastic container. Okay, that is why we call it as pressure. So once I put this one on the thing, because of the pressure, because of the area, then suddenly I feel it's very heavy. So it's pressure on me to hold this a little bit longer. So that is known as pressure. So always remember that pressure is F divided by A, the force divided by A. Sometimes they didn't call it force. So some mostly in engineering we call it load. And so load means force. There are a lot of thesaurus in English. So you cannot use the similar words. So you always just increase. No, try to avoid the words increase. The I see the temperature going up. It's other words. So if you keep use the same word, so people get bored. So when people get bored, let's say for the PSF for final year project, then you got less mark because the examiner is boring. See this girl or this boy use the same word over and over again. So why not try to avoid and use a lot of other words? You can use this day you have what? Grammarly. So the Grammarly can give you a lot of things. So sama ada dengan force ni kan. So instead of force, you can put a load. So the atmospheric pressure. So what is atmospheric pressure? So atmospheric pressure. So why do I can sit on this chair? Why you can walk normally? Is because of this atmospheric pressure. So the pressure due to the force by the atmosphere mass. I'm not sure who the one who invented or the one that found this thing. Because of course this thing is created by the God. But who's the one that found that the standard atmospheric pressure is 101.325 kilopascal? So you can Google it later on, find it. Who's the hell is this guy who find out that the atmospheric pressure is 101 kilopascal? And same as pi is what 3.4, 3.1. 3.4121 what? 3.4215 sampai there is a movie Pi and so you can and then there is also a effect of the pressure. We call it barometer. Barometer is a device that used to measure atmospheric pressure. So if you put into this kind of glass, you have some so-called that's in the working liquid tube. If you put tube on top of it, at certain period you see the amount of water go inside the cube, and the height of the cube you times with the specific gravity of this one, the density, and also the height, and also the density of the water. Then you got what? The gravitational effect. Then it's what? Is you get the pressure. And like if you go into the moon, the gravitational effect have to be divided by something else. 6 or 7 thing. So you got a little bit different back pressure. That's why there is less pressure on the higher latitude. Probably there's a reason. If you live on the mountain, or you will less fat than compared to you live on the ground like here. So if you want to lose weight easily, then go and live in Cameron Island or Genting Island and try this experiment. Left gravitational effect, because the pressure is what? Rho GH. So the higher is what? The pressure probably high, then your intent of eating more is going to be less. No, you can try it. Hey, why not? Dulu-dulu zaman-zaman muda dulu saya duduk main ski dekat Alps kan, dekat belah-belah Italy semua tu kan. So you all tak pernah ke belah-belah Italy duk pergi kan. You all boleh study kat Malaysia, so tak boleh study kat Malaysia. Why? Because there is no snow kan. So I need 4 season kan. So 4 season is what? So when there's time to start the semester, bulan 9 macam minggu next semester, then you see all the water change from green to red, and then suddenly it's dropped by, and then by November it's become a snow mountain. So there's no snow around. When you open your house, you see the snow is coming to your house, and after that it's become the spring. the flowers start to bloom, daripada pokok tu bogel, they start to bloom, and after that the flower drop and the green leaf started coming out from the tree, and suddenly the whole nation become green, and then start back with the fall back. That's why there are two semesters. One is the spring semester, one is the fall semester. Summer is what? Summer is for you to play around. that's why summer is a very long day. That's why you akan cuti bulan 7, 8, 9 kan. So because summer is the only time for European or those who live in the northern period or southern period for them to travel. Because at that time the daytime is longer than the night time. Kalau tidak, in winter the daytime is shorter. Especially the best one is what? The Ramadan. Why? Because we can break the fast early. So for the Ramadan is what? Start at 8 in winter, 8 a.m. and probably about 3:30, 4 o'clock dah boleh buka puasa. Kalau macam dulu saya pergi kelas kan, so wake up at 9, makan macam pagi-pagi saya pergi 8 breakfast kan. At 4, masuk kelas, keluar kelas dalam pukul 4, dah buka puasa. So it's already time to break fast. So it doesn't feel like Ramadan at all. Rasa macam senang kan. So tapi kita kat Malaysia from what? From 6 until 7, so about 12 to 13 hours of fasting. Very challenging. Tapi kalau sama puasa, ambil kau daripada pukul 3 pagi sampai pukul 10 malam. Kita tak tahu nak buat apa saya dulu. Right, another one is known as the tadi barometer, and then one is known as the gauge pressure. Itu kita dah buat experiment. We have conducted a tutorial related to type of pressure. Okay, we have a question that is a gauge pressure. Is the difference between the absolute pressure and the atmospheric pressure? If the difference is positive, kalau difference is negative, that is known as, you cannot call it as gauge pressure. If the temperature is called a vacuum. So if you got the value is less or level is negative, that is called a vacuum pressure. And so these are the pressure. Kenapa you belajar pasal pressure? Contohnya, let's say you all kan electrical engineer. You want to design the amount of electricity for a vacuum cleaner. Contohnya you kerja dengan Dyson kan. So probably the mechanical engineer, they'll design all the system. And then when it comes part to the electrical part, they call it electrical engineer to design it to make sure that the fuel consumption, not the fuel consumption, for car, the electric consumption for that kind of vacuum is less. Okay, so what they call this kind of thing. So they come. So you guys must remember back what you have learned in thermodynamics. So you can know. So the amount of vacuum is what there's these are the pressure difference. So when the pressure difference, so what are the effect of this ampere ke apakah? Saya tak faham sangat. I do not know about the electrical side lah. Electronic side saya tahu sikit lah. Electrical side tak. Electrical is a little bit different kan. Electronic ni yang saya faham jenis Arduino, programming. Lalu elektrik macam you all ni pegang elektrik mati. Jadi saya tak belajar elektrik tu. So saya all like zaman tak cerdik tu kan. So if I learn electrical engineering, I touch the electric, I die. So that's why saya tak ambil electrical engineering. You guys are very powerful lah. You berani ambil lah. Okay. So if you look into this figure, so if you cannot understand what I try to mention, so it's very simple. If you look into this kind of chart, okay. So these are the PATM. So if the P absolute is here and P absolute is higher than PATM, above temperature pressure, that is absolute vacuum. This is known as the gauge pressure. So if negative, like this, so it's known as vacuum, right? Okay, so that's a difference between the gauge pressure and the vacuum pressure. So kalau if you cannot understand what I try to mention, you Google it. Google ni kadang-kadang dia bagi kita wiki ni kadang-kadang dia explain in a very similar words. Of course you cannot use in the exam, but at least they give you some basic idea of understanding. Macam saya belajar kat Korea dulu lah, because you know everything is in Korean. Sometimes I don't understand. Contoh macam dia cerita effect of pressure ni amnyok, so they call it amnyok, gauge amnyok, kata kan. So vacuum amnion, so vacuum pressure. So tak faham apa semua. So what I have to do at that time, yeah, so you have to Google it. Masa tu tak ada Google sangat. So you have to go to library ya. Masa saya dulu kan belajar. You only very simple, you tak tahu apa, you can Google everything ya. Lama saya nak Google sebab handphone masa tu tak apa canggih lagi lah. Itu pun masa tu Korea dah canggih lah. Saya ingat masa tu. Right. Now, let's say you want to use to apply the theory. So you manometer. Okay. So you say, why do we learn this kind of thing? It's very simple. Okay. Nowadays it's already meterized. So basic from the meterized that they design the meter to calculate or to show the effect of the pressure yang keluar ke atas. Let's say the tank for the welding ada gas kan. So the welding yang betul gas semakin turun. How do you calculate this one? How do they know that the pressure is inside the gas tank is decreased? Why? Based on this kind of theory. Okay. So let's say on the right side, okay, so if we look into this, okay, the P1, okay, so the P1 here is the pressure of the gas plus this one, the pressure coming from the gas, which is, you can look into this kind of things on the left side, okay, plus rho g H1, so H1 here, okay. If P1 equals to P gas, okay, so P1 is PA plus rho g H1, okay. So what is the amount of P1 here? So is plus the working fluid. So if the fluid change here, so automatically the pressure one is different here. So the pressure is here, the pressure here is different. Okay. Why? Because of this working fluid. So what you can, sebab formula ni senang faham je kan. So what I want you guys to understand is what? If let's say later on you have to design some materials, okay, so you want to fast calculation atau for fast to show the effect of the manometer punya meter tu, is probably you play around with what, the working fluid, either you use mercury or, that's why in thermometer yang to measure you punya apa tu, blood pressure, body temperature tu, they use what, mercury. Although the mercury is not is a very sensitive item, and it can, let's say one mercury, let's say you there is some leakage of the thermometer, let's say in laboratory ke, in your house ke, kalau dekat overseas, if there is break of mercury tu, walaupun very small, then the lab is going to close about, let's say 1 to 2, 3 months, because the effect is high. The one that invented the mercury, girls pun dah mati kan. So she died because of the material that she invented or she found out. Okay. So that's other things. Okay. So the gas inside here is depend on the pressure A, okay, the atmospheric pressure plus the rho g H1, the working fluid density, gravitational effect, which never changes, 9.81. H1 depends on the amount of H here. Okay. So that's the application of this temperature difference. So nanti midterm dia akan ada satu soalan lah pasal pressure. So normally midterm, ni siapa yang masuk kelas ni tak tidur hari ni, dia tahu lah soalan midterm apa. What is conversion of unit from, let's say 150 Kelvin degree Celsius to Kelvin, Rankine, Fahrenheit. Itu soalan tu mesti keluar. The second one is what? Probably yang aspek yang kita buat itu kan, yang blood IV transfusion. So one question related to the pressure, and the rest is next tutorial. So you know to hint lah. So apa yang kelas hari ni dia tahu lah. Okay. And then variation of that. Let's say you go to snorkeling, snorkeling around, Florida, all these things. You are on the top, let's say on the state one. So your pressure is the amount of the pressure, your body is the amount of pressure of the ATM, the atmospheric pressure. But if you dive kan, bukan swim, kita terjun from the top level of the water, we we go into the deep the ocean, we call it diving. So we dive. So when we dive, what? The pressure that when you are, let's say you dive from here to here, so the pressure is depend on the atmospheric pressure on the tops, plus the effect of height and gravitational and the, let's say this one is a sea water, so the density of the sea water. That's why if you're diving, well, let's say you have a license, padi license. Padi itu bukannya padi pokok padi itu, license diving itu nama padi. Lagi ada tak cerdik tu, dia tengok padi padi mana pula. Mana ada pokok padi boleh terjun. Orang Kedah lagi tak cerdik kan? Right. So the deeper let's say you try to dive, so banyak orang, so a lot of people die because when they're diving, because they forgot to look into their watch, say that the amount of pressure. So human being can, I think, can dive about berapa meter, what? 100 meter. So you ada siapa yang ada lesson diving, how many meter you can go deep? 60 meter lah. Tak ingat 60 meter dalam kan, 10 meter, 50 meter. So because when the more you dive, the pressure will increase, sebab you tak pakai tutup telinga tu kan. So it's based on the pressure yang kat telinga. So what happen is that when you too deep, then you got unconscious. When you got unconscious, you mulalah jadi macam nak mati apa semua, tak sedar. And from there, the ocean will bring you down and then you die. So so now you dah belajar pressure kan. So always watch out for your watch. So 4 meter, 10 meters, and then you go. Tak boleh terus. Tu seronok sangat ikut kan. Tengok dia ikut penyu. Arwah inna lillahi wa inna ilaihi raji'un. Kan dah jalan thermodynamics, I have already taught you guys. Don't go too deep because the pressure is based on the atmospheric pressure on the surface of the water of the sea plus the amount of the height. So less high. So going up back, look at the watch. Don't die, by the way. You die. When to die, then I lost one student. Beei 2463 thermodynamic die because of did not apply the theory of the pressure that they learned in the thermodynamic class. And so we have kenuri arwah. Ila hazratin Nabi yang bahasa. Right. So let's say you have this kind of blocks, okay, you have a dx, dz, and dy, so you have the pressure around it and the P2. So the total pressure is what? The pressure 2 divided by pressure 1. Okay, ataupun specific gravitational plus the amount of delta height z. Okay? Right. Remember that the deeper you are, the higher the pressure. Okay? Same as this kind. Let's say this is a water level. Okay? If you look into this water level, so the pressure at PA, PB, PC, PD, PE, PF, PG. Okay? So they have the same pressure based on P1 atau PATM plus rho G E H, because they are the same point, same level. Although the shape here are not the same. Because what? The pressure doesn't based on the shape of the body, but it depends on the deeper of the length of the effect of height. Okay. Right. So let's say, but however, if the density is changed, the density of the fluid, let's say dalam kan. That's why there are certain not human, certain fish or what's called, bukan fish, nak kata apa, ocean punya life, ocean life. Some of the fish, they cannot live here. The very too deep, banyak bawah-bawah tu kan, so too deep. Why? Because this gravitational punya dia punya density are different. So when the density are different, so not all sea life can live there because too deep. So because of why? Because in engineering we can say that the effect of gravitational rho or density does affect the pressure. So that's why pH not equals to Pi. Okay, if if the mercury here is not the mercury, it's just water, then pH will equal Pi. If the density is different here, although the height are the same, H and I, the pressure will not be the same because this have the effect of so-called rho or density. Why? Density. This because the density itself is known as, yes, intensive properties. Kan tadi awal-awal kita aja what is intensive, what is extensive. Yang duk masuk keluar tu saya nampak kalau dia ni masuk, lagi lagi Ramin masuk, saya kira ni keluar, lagi kawan dia keluar kat point kan. Kawan-kawan you lah masuk keluar, tak tahu lah apa masalah internet kampung kan. Okey. Yang tak ingat tadi tu Pak, extensive depend on mass, intensive that depend on mass. What are the three intensive properties? Density, pressure, temperature. What are the extensive properties? Volume. Okay. Right. So the measurement of the temperature. Ni soalan midterm ni famous ni. So jangan lupa, jangan pakai formula lain, pakai formula ni. Okay. So kalau you tengok soalan tutorial 1, soalan nombor 1, soalan nombor 2. Okay. So how to convert from temperature degree Celsius into Fahrenheit, into Kelvin, into Rankine. So these are the formula. So you look up into this tutorial, my YouTube channel, then there is a solution. So very straightforward. Ini budak je satu pun boleh pakai, boleh calculate. You all pun dah banyak kali. That's why saya tak tunjuk masa tutorial itu. So it's a very straightforward punya question. Soalan senang-senang ni, you all straightforward ni, itu pun, there are few students that got 0 for this month. I don't know what's wrong with them. It's a very simple. So now, so this is the most challenging part starting now. It's not that challenge. The challenge is the next chapter. Right, so what are the zero flow of thermodynamics? Okay, let's say you have iron, you have a copper, so you join it together. Okay, so different, the iron is what, 150 degrees Celsius. The copper is 20 degrees Celsius. Touch each other, and the copper kiss the copper. The iron kiss the copper. So 150 kiss 20 degrees Celsius. At the end of the process, both have 60 degrees Celsius and 60 degrees Celsius. Both for iron and copper. So what is different is what? So this one is phenomenon is known as the zero flow. So zero flow is what? Zero flow ni, saya cakap sudah saya, this law of the kunyit. Geng-geng kunyit lah. Pak Arab tu tahu dah, kunyit tu tak tahu lah. If two bodies are in thermal equilibrium with a third body, they are also in thermal equilibrium with each other. So I have 3 water. So this one have 3. This one is a little bit hot. This one is suam-suam kuku. This one is cool. So the 3 gelas kan. So cool down. Anyway. So this is hot. This is 3 temperature. So this one touch this one. The body A, the teh tarik touch the cool water. So it's become, so this one 90 or 20. So now it's become 80. So this one is 60 IS1. So it's joined together. At the end of the process, the change of the thermal transfer, the temperature transfer here, and the change, okay, they become a thermal equilibrium. Okay. So at the end of the process, all these 3 bodies have the same temperature. Let's say 60 degrees Celsius. So these are known as this zeros law. So the zero is what? 2 bodies are intermediate will both have the same temperature anywhere, even they are not in. Okay. Right. Okay. Amir left the meeting. Zahir, mana Zahir? Tidur saya. Aku tak suka tu, cakap aku tak suka saya tu. Dia tipu tu, cakap. Kan? Ni, mana Zahir dia cari Zahir? Zahir. Tidur apa ni? Tak ada pun. Aku dah cakap lah. Siapa yang perempuan jangan kahwin dengan Zahir tu. Dia tak suka dia. Right. Dusta. Right. Now, form of energy. What sort of energy that we have in this world? So we have thermal energy. Thermal energy. So if you go into this, kita tak ada gunung berapi kan? If you go, at least you want to go to the nearest one is what? In apa? In Indonesia, nearby Bandung tu kan ada lah kot. There is lava, volcanic. So there is a thermal energy. And then we have a mechanical. So mechanical energy. So if your car move, then the car itself have mechanical. If the car move and it creates some energy, so it's become kinetic energy. So the mechanical energy from the engine convert to kinetic energy of the car, so the car move. And then we have the potential energy. So potential energy, let's say you just sit on the top of the ground and compare to the top of the mountain, and so you have the difference between the H side. So you have the effect of gravitational, so it's a potential. And the one is electric. Okay, electric energy. So you guys are electrical student, and then you got magnetic energy, and then you have chemical energy, and also you have nuclear energy. Okay, saya pernah ada dulu one of my supervisor dalam kelas, I think kelas engine kelas ke. So kan dia Christian kan, dia I swear in the name of the Holy Father, Jesus, and this Holy Ghost. So the Trinity concept. There will be no other energy that can replace oil other than nuclear energy. Cara cakap macam tu. Well, maksudnya dia kata, there is no other. And probably that's the reason why the American invaded Afghanistan to get the uranium. So why? Because they want nuclear. I don't know. Tak ada siapa nak invade Malaysia. Malaysia tak ada ni kan. Sudahlah Zain, kau tipu aku, kau ada sini. Tipu. Sekejap, jam saya berbunyi. Wait sekejap. Zahir pendusta cinta. And then we have two type of total energy. So the one is called as macroscopic, another one is microscopic. Macroscopic means you can see. So anything at all. Macro you can see. Micro you cannot see. You have to look into underneath of it. Apa tu yang kita tengok? Yang kita duduk teropong tu, teleskop lah. Horoscope. Apa nama tu? Lupa lah. Microscope. That's why I call it microscopic. So it's a molecular structure. So kalau dalam thermodynamics, thermodynamic 3. If you're pure mechanical, then you have thermodynamic 1, 2, and 3. The second one is more related to the exergy, and the third one is related to the molecular punya structure punya energy. So you guys need to look into the macroscopic. For thermodynamic 1, it's more likely a macroscopic. You can see change of this energy. So from potential energy into the kinetic energy. Okay. Right, so that's different between the thermodynamic 1, 2, 3. You guys have belajar thermodynamic 1 saja kan? Okay. And then so macroscopic energy, you can see the motion. Okay, and then you can see the influence of the external effect. So, can you see the electric? You pernah electric kan? Can you see electric or not? You pernah tengok electric kan? Pernah?
Tak pernah tengok.
Tak pernah tengok? Betul korang budak elektrik? Betul ke tak pernah tengok elektrik?
Lightning pernah.
Lightning tu bukan elektrik kan?
Kat Tesla. Tu je lah pernah tengok pun.
You tengok kat Tesla? Macam mana you tengok kat Tesla? You pergi Tesla?
Kat TV je lah.
Oh, saya tengok. Saya pernah tengok elektrik tu. So kalau dulu masa saya duduk Belanda, you tahu kan tim PSV Eindhoven kan? So PSV Eindhoven tu, saya duduk Eindhoven 2 tahun lah dekat Belanda tu. So Eindhoven ni dia ada special festival. So special festival ni dia known as Eindhoven Light Festival. So masa light festival tu Department Elektrik dia akan tunjukkan macam mana dia nak set up apa tu lightning. Lightning, bukan lighting tu lampu, lightning kan. So it take about 1 second dia nak generate from one step tu. Itulah first time saya tengok elektrik. Dia tutup satu universiti punya ni kan. Semata-mata dia nak generate satu elektrik untuk nak jadi lightning tu kan. Pom, itulah first time saya tengok light. Dia kata, sekejap betapa laju. Itulah first time saya tengok elektrik. And yalah kita tengok lighting tu ni kita nampak macam cahaya je kan. Ini memang betul dia bagi bentuk macam mana elektrik tu nampak. So, memang cepat elektrik. Memang kita kata tak nak tengok. Habis lah. That's why the speed of light. Dia terlalu laju sangat elektrik. Kan? So kalau you nak tengok, bolehlah esok. Kalau you all ada duit banyak, bulan 11, selain daripada tu you boleh tengoklah Eindhoven dekat apa tu, Eindhoven, PSB Eindhoven main bola kan. So one of it, second one is you go to in November, you boleh tengok apa ni, Eindhoven Light. Eindhoven Light Festival. Memang itu situ dia banyak. Dia buat satu bandar tu cantik. So you boleh jalan kaki. Janganlah duduk Malaysia tu je, pergilah travel kan. You kan anak-anak orang kaya semua. Macam saya orang miskin terpaksa lah belajar rajin-rajin nak pergi tengok benda-benda ni semua. Kan? Right. Okay. So now we have this kinetic energy. Okay. And then we have this potential energy. Okay. So potential energy means from, let's say from top of the mountain, you're going down. So it's from potential energy plus kinetic energy. Let's say from 10, now it's become 7 plus C. Okay, let's say you must have the effect of motion, after you move the car and half mv squared. Okay, so you just have kinetic energy, right? So magnetic and surface tension, we normally we ignore. So dalam soalan thermodynamics untuk thermo buat tak ada benda ni semua, right? Sebab tapi kalau you all yang budak electrical electronic, you all lebih concentrate benda yang tengah ni lah, magnetic, electricity, surface tension ni. Kami tak tengok sangat benda ni, kami unit ignore. Unless it's a radiation. Radiation ni ada effect. So orang mechanical dia tak tengok sangat. So orang electrical dia tengok. Okay. So the total energy. What do you mean by energy? So energy is what? Kalau kita kata energy, we have internal energy, kinetic energy, kita ada potential energy. Okay. So internal energy is U. Nanti kalau you all dah print thermodynamics table, you have printed the thermodynamics table, U, kalau you tengok nanti dekat belah kiri sekali tu ada U. Kan? U, H, S. Nanti kita akan tengok in details later on lah. Saya akan ajar macam nak guna. So the energy. Even there is no kinetic energy macam saya sekarang lah. So I'm in a static condition. So I don't move anything. So let's say I'm static here. I'm touching my body. So I'm not on the top of the mountain. Okay. Now what happened? My energy is based on my internal energy. If you don't have internal energy, you are die. You already macam sebab tu orang mati tak boleh bergerak semua. Dia senyap. Why they don't have internal energy? Okay. That's why we are human being. We have internal energy. Although we didn't move, although we are in the low condition punya, bila low ground ni maksudnya tak ada gravitational effect. Kalau senang, if I say that there is no gravitational effect, that means atas tanah lah. If I say there is gravitational effect, that means the problem is on the top of the mountain. Faham tak? And then kinetic energy is what? If there is movement, there is a kinetic energy. If there is no movement, there is no V. V is what? Speed. Okay? So there is no energy. So there is what? So the energy equivalent to internal energy. Okay, kalau saya bangun tadi, macam saya bangun, pergi tutup saya punya phone, saya masuk balik sini, so saya dah apa? Internal energy plus kinetic energy. Katalah rumah saya 2 tingkat, if my house is it's a 2 floor punya house and so jadi saya kena naik tangga, I have to climb the stair second. So that means what? I have internal energy from my body, I climb the stair, so I have to conduct the kinetic energy. At the top of my house, the second floor, I have gravitational effect. That means the energy there on the second floor, when I switch off my phone, I have total energy is what? U plus kinetic energy plus potential energy. If I just go there, because rumah semi is just one floor only, so there's a internal energy plus kinetic energy. If my phone is just here, my second phone is here, so that's mean my energy is what? Just internal energy. I didn't do anything at all. So that is different between, and that is not that is what we so called as energy. Okay. Right. That's why you belajar thermodynamics, very simple. Okay. And then we have normally yang tadi yang application lah. So kalau kita tengok a very simple punya program proses, kalau macam ni dia closed system, so mass boleh berkurang, mass biasa tapi volume dia boleh berkurang sebab dia bertukar ke from solid into this so called steam. So dia akan jadi rendah tapi the volume, the mass will be the same. So that's mean it's closed system. If I open this one, so it's open system. That's mean the mass can change. Tengok tak percaya mass change kan? Tengok saya minum air. Why? Because this is an open system. The water move into my body. So it's less now. So the mass from 350 milliliter now is 250 millimeter. Kan? Okay, so kalau open system, they have all this internal energy, kinetic energy, and potential energy. Sebab apa? Macam saya minum je, berapa banyak ni nak bergerak. So daripada bawah dia naik ke atas, so if gravitation effect, and then they move into my mouth, effect of kinetic speed kan, the movement of speed, V. Ini V speed bukan V volume kan. And then there is internal energy because I have body myself for me to raise this thing up. So that is open system. Okay. Kalau orang lain ajar, dia tak ajar, saya ajar, dia tujuh KE sama dengan U plus KE plus PE. Now we have this molecular structure and the molecular activity. Okay. We have the internal energy, we have the sensible energy, kinetic energy, latent heat of phase. Okay. And then we have a nuclear energy. So nuclear, why did my professors swear on the nuclear energy? Why? Because it has a strong bond within the nucleus of the atoms. Okay. Okay. So the nuclear bond is very strong. That's why when something happened to this nuclear power plant, so normally they just leave this whole city at itself for at least 10 to 20 years. Macam Chernobyl dekat Russia, until now, nobody ever have brave enough to go there. Even you yourself, now I give you a ticket to go to Chernobyl, I don't think that you guys are going to enter that thing. Probably once you leave the system, not leave the city of Chernobyl, you mati pucuk. Yeah, there are a lot of things because of the radiation effect. You don't know anything. You don't know what sort of things that can change it. And even kalau chemical still okay lah, habis kuat pun you mati je chemical kan. Kalau nuclear dia tak mati tau. Then probably you have some defect. Dia macam tu. Tu bahayanya nuclear. Dia kalau mati kalau terlalu kuat sangat lah. Kalau chemical ni macam bom chemical, dia mati. Kena dia mati. Right. So tak penting lah sangat tu. Okay. So now, okay. If a specific heat, so lepas ni ada perkataan specific heat. So the specific heat is what? How the engineer coming up with this kind of word? So its experiment show that the temperature rise of liquid fluid due to the heat transfer to the mass. Okay. So one of the way to describe heat is what? We use the mass of water times the specific heat, which is the experimental factor. Normally we got from the textbook ataupun saya bagi dalam question. Times the temperature different. Temperature different ni from state 1 to state 2. So dalam soalan nanti dia akan baca di sekarang. So state 2, this one, state 2, blah, 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 blah. So calculate the heat transfer to the water. So M is based on the question given the mass, and then Cp given by the question, and the temperature. You have to know what is state 2 and state 1 punya different state punya temperature. So normally C is given by the question, M is given is from the question, T is from the question. It's either 3 or 2 must be given by the question. Okay. If an open exam book, then you can find the C by yourself. If the exam normally is closed book, then C is given in the question. Sebenarnya in my apa dia?
Terus dia depends pada substance dalam air ke, pure ke, macam mana?
Yes, depend on the substance of the water ataupun items tu ya, ataupun liquids ke gas ke yang kita refer to this kind of thing. So gas nanti kita akan tengok soalan ni ada dua jenis. Satu water, satu lagi one is ideal gas. So kalau ideal gas kebanyakannya we use this formula. Water we can find the material, the specific punya properties tu daripada thermodynamic table which I've given you guys last week kan. Tapi kalau ideal gas macam nitrogen apa semua, then CPs will be given. Soalan ada dua ya. So kalau ideal gas you don't have to refer to table. Kalau kata water then you refer to the table. Okay?
Right.
Okay, so jangan risau. So kalau MC2 peristiwa ni normally is ideal gas. Soalan nanti ideal gas dia akan pakai soalan ni untuk calculate heat. Tapi kalau soalan tu water, dia start with water, steam apa semua, tak payah pakai formula ni. Kita pakai formula yang kita can extract from the thermodynamics table. Right. So the specific heat of solid and liquid is not only a function of temperature, but specific of generous gases, substance is a function of temperature and process. So ini nak explain a little bit about this equation ni lah. Okay. Right. So this dia ada specific heat, dia ada untuk constant volume. So the same formula and the same, but the way they look into the other side. So engineer ni dia suka tengok satu soalan dia akan tengok belah sini, satu soalan dia tengok the other side. So they are the same but different angle of you guys take into look at it. Kadang-kadang student they confused why the specification there was CV and CP. It's the same thing but different kind of. Why? Because there are people like me or probably like you guys doing PhD, and so you want to invent a new knowledge, and so when you enter the new knowledge, you make the younger generation stress. And then CP, CV. So you all wonder you buat PhD mungkin ada CPV lah. You combine both these things, you look into the three-dimensional side. Okay, so the constant process based on this formula. Okay, so tak apalah. Right, so these are CP and CV. Okay, so kita nak mention is what? Specific heat at constant volume is change of specific internal energy with respect to the temperature when the volume is held constant. So it's a correct process. Dapat parameter from 1 to 2, right? So and then if you look into the different angle, okay, so 1 to 2, let's say it is known as the constant pressure but change in volume. This one is known as the isobaric process. Okay, there are two process yang you boleh tengok. Okay, there are some process isochloric, one are isobaric. So isobaric means the pressure, sebab the word bar is the pressure. Okay, so that's why in this question dia akan jadi dapat MCP ataupun MCV. Okay, so CP atau CV nanti depends on the question give. So senang je lah untuk you all sebab you all budak electrical electronics. So tak details into this kind of CP CV. Even budak mechanical kalau kata FTKMP pun tak detail sangat lah sebab they are more about troubleshooting kan. You guys pun lebih kepada hands-on punya application kan. Kalau details ni engineer more towards the complex problem kan. Okay. Tapi lebih kurang, tapi kalau nak pasal tu lah CP dengan CV ni normally dalam question kita akan bagi je lah. So you all will use. Okay. So now, apa beza heat dengan work? Okay. Right. So heat, energy transfer between two systems by virtue of a temperature different. So from hot, you give 5 kilojoule per second heat lift to, so it's become cool. And then it's known as heat. Ataupun you give from low temperature increase to the high temperature. That is also called heating process. So heating process ni maksudnya either you heat the system ataupun you cooling down back the process. Itu pun kita panggil sebagai heating, part of heating process. That's why they call it heating and cooling. So that is a reversible process. Contoh macam ni. Dia dah cool. Saya punya teh tarik kan. Sedapnya. Yeah, so dah cool. Tapi kalau saya masuk dalam microwave, I tune back 800 megawatt, then it's become hot again. So heating process. So heating, cooling, heating, cooling, heating, cooling. And then when there is a work, and they define the work is what? Energy transfer associated with a force acting through a distance. The effect of distance. Okay, that's it become work. And normally work are based because there is change of distance. It has effect of time. So, jadi work ni dia dalam bentuk per second. Kilojoule is probably heat, that's energy. Energy per second is work. Okay. Untuk heat, if heat is given to the system, let's say you heat up this water, it's known as positive. If the heat coming out or its cooling process is known as negative. If you give work, let's say you want to switch on the refrigerator, the work you give is known as negative. Let's say you come out with a turbine, the water leave the system, so the electricity generated by the turbine is known as positive work. So work that generated by the system is positive. Work that need to generate the system is negative. Work generated by the system is positive. Heat through the system is positive. Heat leaving the system is negative. So positive means heat, negative means cooling. So positive work, negative work means that you have to give electric or you have to give something to generate the work. Or if let's say if your work coming out from the process, let's say the turbine from the tasik kenyir, they generate electricity. That the work coming out from the tasik kenyir turbine is known as positive or described as positive work. Right? Right. So that's it for today. Sorry, a little bit long. So yang those who you have to use data tu, sorry lah, tak boleh short sangat, tak short sangat pun tak boleh. Tambah next week lagi susah nak short. Why? Because there will be a lot of questions. So make sure from next week, okay? So Tuesday night at 8:30 as usual. Okay, and then Friday as usual. So kalau boleh you come, you join the Tuesday night sebab saya akan teach you guys how to use thermodynamics table step by step. Well, if you don't join, then on Friday, it's more likely it's the same things, but it's much more forward, much more faster than explanation than the. So I will teach twice. Okay, so because it's quite challenging to understand the thermodynamics table for probably about 80% of the student in this class is going to have difficulty in reading. So saya akan ajar benda not benda yang sama. It's the same things but different problem. So kalau you lost the Tuesday night punya lecture, which is not compulsory for you to attend, then the different problem on Friday morning, then it's just a repetition process. So you can mungkin lebih faham lah. So kalau you join mana, the same thing tapi jawab soalan lain pula kan. Soalan lain. Jadi you dapat dua ilmu daripada mana satu ilmu. You have a lot of example. Macam latih 2B SPM pula. Right. Okay, so see you guys on next Friday, on optional on Tuesday night at 8:30. Right? Okay. Alamak. Saya nak ambil attendance.